All right, so now we move into lesson 6 of polynomials, and it's factoring algebraic expressions. So the first thing we want to talk about right away is saying, well, what does it mean to be a factor? Or more specifically, when we looked at factors in number sense, what did that mean? Well, it meant we took a number and deconstructed it such that we had a bunch of numbers that could multiply or be some form of multiple to get to some other number. So if we have factors, or specifically numbers that we can multiply to get another number, well, we can also expand upon this and say that some of the factors that may be the same or common to other numbers, we call these common factors. So let's see how this relates to factoring algebraic expressions. So if we look at our first one here, we have 4m plus 12, and we're supposed to factor this in a couple different ways, meaning what is something that is shared in this expression between the two numbers? If I look at 4m and 12, or more specifically, 4 and 12, what is the same about these? Well, if I removed a common factor of 2, then I could rewrite this expression as 2 times, well, 4 divided by 2 was 2m, and then 12 divided by 2 is 6. So I could express it as this. Now, I could also express it as, what if I took out 4? So I put a 4 out front. Well, that would leave me with 4 divided by 4, which is just 1m. And then 12 divided by 4 is positive 3. So here's two different ways I can write it. I can write it with a 4 being the common factor, or a 2 being the common factor, because we know 2 and 4 are both things that divide evenly in this case to both of those numbers. And so here's a couple different ways we could represent this as a product of factors. Now, which one is the most complete factored, or which one is the most completely factored? The most completely factored one is the one that leaves only prime numbers, or the one that takes out what we used to call in the number sense unit the greatest common factor. So if we remove the GCF of the numbers, we know it is completely factored. So remove out the largest number that's shared between the two of them, or the largest factor, the greatest common factor. This means we know it's completely factored. So let's take a look at the steps required to factor algebraic expressions. And this is to always look first at the GCF for all individual terms. So let's take a look at some of these examples here. If I look at the coefficients here, 16, 24, and negative 4. What's the greatest common factor, or the largest number shared between those? Well, it's actually going to be equal to 4. Because if I take out a 4 from each of these terms, well, 16 divided by 4 is equal to 4. So I'm going to be left with 4a on the interior. 24 divided by 4 is positive 6b. Negative 4 divided by 4 is negative 1, and I'm left with the c attached to it. And there is my factored form. I've removed the greatest common factor. If I look on the interior, I should not be able to remove any more numbers. And in this case, there's no more things that we can remove, meaning I found my GCF, or the greatest common factor. Let's look at a couple more examples here. So if I look at my next one, now I just have variables. How many x's are common in this case? Well, the greatest amount of common x's is x3, or x cubed. So if I pull an x cubed out front of this term, I have x cubed. My two terms were x5 and x3. x5 divided by x3 is equal to x2. And then I have x3 divided by x3, that's equal to just 1. So here is my factored form, removing out that greatest common factor. All right, in my next term here, I have 30p4 minus 12p7. Well, this one actually involves numbers and variables that I can remove here. So if we think about the greatest common factor between 12 and 30, well, that would most likely be equal to, in this case, I believe it to be 2. And now if I look at the p's, I have P4, P7, the greatest amount of shared factors, or the greatest common factor, is P4. So if I remove out a 2, P4, this leaves me behind with 30 divided by 2 is 15. P4 divided by P4 is just P0, which is that case just 1. Negative 12 divided by a 2 is negative 6. P7 divided by P4 is P3. So there is my two factors, or what we will come to know as factored form here by removing out our GCF or removing out some form of common factor. All right, in my next one, I have a 5xy minus 3y. Well, 5 and 3 actually aren't going to simplify here. I can't remove out anything in regards to the coefficient numbers. So now I look to the variables. Well, there's an xy and a y. I'm going to remove out that common y. So y is my GCF, therefore giving me y times 5x minus 1. Or in this case, I need to correct this and make this equal to a 5x minus 3. So I've taken a y off both of these terms to rewrite it as such. In my next example here, I see I have a 5x multiplied by y minus 2, a negative 3 multiplied by y minus 2. Well, what do both 5x and negative 3 share? It's that yx or y minus 2 here. So my greatest common factor is y minus 2. And now what do I have left? I have y minus 2 on the outside, which was the greatest common factor, and the remaining terms were 5x and a negative 3. So I piece those together, 5x minus 3. Finally here, I look at example 6 and I see, okay, a 4m is being multiplied to 2n minus 5. A 7 is being multiplied to 2n minus 5. What is that shared term between 4m and 7? It's the 2n minus 5. So I'm going to write this as the greatest common factor, 2n minus 5. I bring it out front and say 2n minus 5. The two things that I was left over or had left over were the 4m plus the 7. That becomes my second bracket here, 4n plus 7. So we removed out our greatest common factor, or the common term here, 2n minus 5, and it went out front of the term. What was I left with? 4m and 7. Okay, so factoring techniques. Factoring is the opposite of multiplying. It is important to realize that we will be using this a lot going forward. When we factor, we're technically taking a number and removing it outside by dividing by that number. So let's take an example 1 here and take a look at this. Well, what is the greatest common factor between 5 and 10? We would know that to be 5. So I can rewrite this as 5 times. If I removed 5 out, this was like me saying I had to take this statement, 5x plus 10, and divide everything by that greatest common factor, which in this case we said was 5. So if I divide everything in this bracket by 5, that's going to leave me with 5x divided by 5 is x. 10 divided by 5 is plus 2. And we know it's the greatest common factor when nothing else can be removed on the interior here, which is the case here. All right, let's go to example 2 or example 1, part B. If I do the exact same thing, I'm going to say, what can I remove from both 3x squared and a negative 6? A greatest common factor in this case is 3. So if I divide both terms by 3 or move a 3 to the outside here, 3x squared divided by 3 is x squared. Negative 6 divided by 3 is negative 2. And now I look at the interior and I say, is there anything more I can do here? No. Finally, example 1c here, I scroll over and I have 3 terms, so this is a trinomial and I want to factor out something common. I'm going to start with the numbers here. So I'm going to write this above, 12x4 minus 8x3 plus 4x and x squared, that is. What's common here? They can actually all be divided by 4. And not only can they be all divided by 4, but they can also be all divided by an x squared term because they at least all share x squared. If I do this, my term then becomes, this is equal to 12 divided by 4 is 3. x4 divided by x2 by quotient rule is x squared. Negative 8 divided by 4 is negative 2. x3 over x2 by quotient is x1. And finally, 4 divided by 4 is plus 1. X squared over x squared is x0. My statement can be written as 3x squared minus 2x plus, we know anything to the power of 0 is 1. So now I just have plus 1. There is my statement. And what I need to add to this, I totally forgot here to include this, but we need to make sure that this is equal to, or before the equal sign, I need to remove out the 4x squared outside of the bracket, because if that's our greatest common factor, it has to go outside the brackets, and everything that it was multiplied to, or everything we divided in this case, needs to go on the outside as the greatest common factor. So our term should include this 4x squared on the outside. Okay, note, a common factor does not have to be a monomial. A common factor, just like we saw in our table on the previous page here, our greatest common factor could be a binomial or 2 terms here. We had 2 terms for both of these. It could be something even larger, but in most cases, we're either going to see a monomial or 1 thing taken out or 2 things taken out. So if I scroll back here, let's look at some examples where our factor does not have to be the monomial and instead could be more than 1 term taken out. Okay, example 2, like we said in the previous page as our warm-up, if I have x and it's being multiplied to x plus 1 and 3 being multiplied to x plus 1, well, clearly x plus 1 is the piece being shared. So I'm going to take this and write x plus 1 out front. What am I left with? I'm left with x plus 3. So x plus 3 becomes our second term here. If I go over to example 2b, well, in this case, I have a 2 being multiplied by a minus b, a 3 being multiplied by b minus a. Are these common here? Not yet, actually, because what we should notice, or what we should pick up, is a minus b and b minus a, they're opposite order. In order to force them to have the same order, I'm going to go 2, a minus b, and in my second bracket, I'm actually going to flip the signs by removing the negative. If I see this negative here, and they're opposite, so I have a minus b in this one, and I want to force my second bracket to look like a minus b, I'm going to remove a negative out front as a common factor, meaning this becomes negative 3, a minus b. I'm doing the opposite of what we've learned in previous lessons, where we said if I had a negative out front, I distribute it. Now I'm going backwards and saying if there's a negative in here and I want to flip the order, I can remove the negative and then reverse both the signs again. So now our greatest common factor is equal to a minus b, because a minus b is multiplied to both. So I pull the a minus b out front. What am I left with? 2 minus the 3. So we have 2 minus the 3. And what does 2 minus 3 simplify to? A minus b times 2 minus 3, which is negative 1. And this could be written as negative a minus b, because we do not have to write that 1 in there with it. We can say that a negative 1 could be simplified to just writing a negative here. So this is a valid way to express this. All right, now we go down to C here. C, I see that if I look at the bracketed terms, I have a minus 2 times some number, and I have a couple things going on in here. I need to realize that just like our note said earlier, looking to pull out a greatest common factor is always the first step. So I'm going to take out a greatest common factor from my first bracket. What can I divide out from both 2a squared and 4a? Well, I can take out a 2, and I can take out an a, leaving me with a minus 2. Because we know 2a divided by 2, or 2a squared divided by 2a will leave me with an a, and 4a divided by a 2a will give me just negative 2. This is plus 5a minus 2. And now I say I have some term, and they're both being multiplied to this a minus 2. The a minus 2 is a common factor, or the greatest common factor between these two. So it's going to be written out front. What am I left with? 2a and positive 5, and they come together in my second bracket. Now we know by distributive property that I could reverse this and say 2a times everything in the brackets and 5a times everything in these brackets. That's going to reverse this back to my original statement. So if you really wanted to, you could reverse this, but we know that this is our greatest common factor and we've pulled it out front. All right, now let's introduce factor by grouping. Factor by grouping is saying if we have a polynomial with 4 terms, another form of removing common factors is called factoring by grouping. So to factor by grouping, to do this specific method, we have to group the polynomial into pairs of 2, factor each of the pairs of 2, and then remove a common factor. So let's take a look at the example here off to the right. Suppose I give you this 4-term polynomial here. Well, in order to group this, I'm going to take my 2wx and my 10w and put them together to make one factor. And then I'm going to have 7x and 35, and those come together to make 1. Now, I look at these individually, the 2wx plus 10w, 7x plus 35, and I take them and I say, what can I factor out of the 2wx plus 10w? I can remove out a 2w that's common, leaving me with x plus 5 on the interior. If I look at 7x plus 35, I can take out a common 7, leaving me with x plus 5. And finally, just like in our last examples, when I see this binomial that's constant between the two, I can remove it out front and piece together the things that I have left. So let's try a couple of examples of our own here. Example 3a. I'm going to do this by grouping. I pair the first two, pair the last two. The greatest common factor in the first bracket is x squared. And that's going to leave me with x3 divided by x squared is x. X squared divided by x squared is plus 1. In my second brackets, I can remove out a positive 3 as the greatest common factor, or divide them both by a positive 3. This leaves me with x plus 1. And now I'm in the situation where I see something and something being multiplied to the same factor here. So I'm going to take that x plus 1, write it out front, and pair together my remaining 2 terms. There is my factored equation, or piecing this together by the split method, in this case, pairing them, or creating groups that I can factor. Okay, example 3b, let's do the same technique here. So I'm going to take this and split them into groups of 2. First 2, last 2. If I do this now, I can remove out a common term in the first bracket of 2x squared, leaving me with x minus 6x squared divided by 2x squared is equal to negative 3. And in my second bracket, if I can't remove anything, well, what's a coefficient I can remove is just plus 1. What does that leave me with? X. Negative 3 divided by 1 is equal to negative 3. I know they're both being multiplied to this x minus 3. That's a common term here. So I take that and I move it out front. X minus 3 times I have 2x squared plus 1 left behind. All right, now I go to example 3c. Doing the same technique, I pair the first 2, pair the last 2. Now there's a reason that I've included this negative in the second bracket here, over here. Here's what we're going to do. In my first bracket, an a squared plus ab, there's a common a. A squared divided by a is a. AB divided by a is just b. In my second brackets here, I see I have a -2 and a -2 on both these terms, or a 2 attached to both. I want to remove out this negative. I then look at it and say, what do I have left? Well, for this one, if I remove out a -2, and A, B are not similar to each other, meaning I can't remove out an A or B in the second bracket, this is going to become, if I remove the negative out front, A becomes positive. And if I remove the -2 from the B becomes positive. Finally, I look at this and say, I have some term and some term, and they're being multiplied to the same bracketed term. I'm going to remove out the A plus B out front and pair together my remaining terms together, making A minus 2. There we go. So we have factored this by grouping or pairing the first two and the last two together for all three examples here. All right. A note before you do your check your understanding or your practice. When we're dealing with polynomials, we always want to look for the GCF of the polynomial. If we can remove out anything from any given polynomial, it's very, very important. Remember, the GCF can be any size polynomial. So we can have a GCF of something with 5 terms, 6 terms, 7 terms. It's really important to look really carefully, no matter how large the polynomial. And then finally, just always look for the GCF, because it's a way of simplifying. And later down the road, we're actually going to see it's a way of helping us factor or get specific results out of polynomials. All right, do the check your understanding.